Welcome to part 3 of the video. In this video, what you're going to do is learn how to calculate the value of R. The work involved is not difficult, it's just a lot of steps. So, a sample of 12 students from June 2013, so this is real data, had the following Unit 1 test marks and final marks. So what I want you to do is to create a scatter plot illustrating the data. So make sure these are the x values, so they go along the x-axis. These are the y values, so they go along the y-axis. So a point of 81, 85 would be about, 81 would be about here for the x, and 85 would be here, so you would plot that point right there. So press pause on the video, please, and plot all 12 points on this grid. Welcome back. So your scatter plot should look something like this, or at least something close to that. What I want you to do now is to draw in a line of best fit. When you draw the line of best fit, what you want it to do is to pass through as many points as possible, but what's more important really is that you have the same number of points above and below the line. So take a minute, get a ruler, draw a line of best fit through the center of the data and have the same number of points above and below the line. Now, when you just make a line of best fit freehand, it's really just to do your best. I kind of have more points above than I do below, but that's not such a big deal. It does kind of look like the line has gone through the center. Just do your best to even out the points above and below. If you had like 10 points above and 2 points below, then you're not really getting the best line of best fit. The next thing I want you to do is to go find your Unit 1 test, and just down here what I want you to do is write down what your Unit 1 test mark is. So just as an example, I'm going to pick 70. And I want you to use your line of best fit to predict what your final mark would be. So your mark is going to be whatever. I'm just using 70 as an example. So you're going to, let's get a different color. So if I got a 70 on my Unit 1 mark, bring it up to the line of best fit. And then bring it over. So I would predict that my final mark would be about 72. So if my Unit 1 mark was 70, it looks like my final mark would be about 72. So do that for yourself. So that's my Unit 1 test result. My final mark was about 72. So press pause, take a minute, and do that. Alright, so welcome back. Hopefully you have predicted your final mark. So, Mrs. Green decides that rather than wasting everybody's time, she will just use this model to determine your final grade right now. Would you be happy with that? Would everyone be happy with that? Explain why this model may or may not be the best predictor of final grades. So just take a second and think about what may be wrong with using this model to predict everyone's grades. You could say things like it's not a perfect correlation. You can say things like it's a small sample size. You could say things like it doesn't take into account individuals' efforts or work habits or things like that. There's lots of things that you can say. So now to calculate the correlation coefficient. So I will provide you with a list of steps after I have discussed them. But for now, the first step in calculating the R value is to count how many pairs of data you have. We have 12 pieces of data. The next thing you're going to do is you are going to multiply each x value by its y value. So 81 times 85 is 6,885. So press pause on the video, take a minute, and multiply each x value by its y value. Alright, so there's the values that you should get when you multiplied the x and the y by each other. The next two steps are to square the x values in this column and square the y values in this column. So here would be 81 squared, which is 6561. And then here would be 85 squared, which would be 7225. So in this column, square each x value, and in this column, square each y value. So press pause on the video, take a minute, and square all those values. Alright, so that's what you get when you do those squarings. The next thing you're going to do is you're going to add up the values in every single one of these columns. So you're going to add up all of the x's, and you're going to put the sum here. So that would be equal to 843. So press pause on the video and take a minute and add up each of these rows. And the last thing that you have to do in the table is this sum, so the sum of the x's, you have to square that number. So 843 squared is 710,649. And then you have to square the sum of the y's. So 859 squared is 737,881. So that's all the completion of the table. And then now what we have to do is substitute the values into this formula here. The biggest difference that you need to know the difference of is this and this. This one here is the sum of the x squares. So here's the x squares, there's the sum. This one here is the sum of the x's squared. So here's the sum of the x's, and here they are squared. So this one is the sum of the x squares, which is here. This here is the sum of the x's squared, which is here. And the same goes for the y's. So here is how we substitute into the formula. So r is equal to n, which is 12, times the sum of the x times y's. So this column here was the x times y's. So the sum was 63203 minus the sum of the x's. So this was the x column, so the sum was 843 times the sum of the y's. So this was the y column, so the sum is 859. This is all over, and you've got two big square roots. The first square root has n, which is 12, times the sum of the x squares. So again, this was the x square column, and there's the sum. So that is 62,903 minus the sum of the x's squared. So here's the sum of the x's, and here it is squared. So you're subtracting 710,649. And the second square root, once again, is n, which is 12, times the sum of the y's squareds. So these were the y squares, so there's the sum, 64,287. Now, sorry, I made a mistake in this formula. There should be a subtraction sign right there. So if you can make that change. So we're going to subtract the sum of the y's squared. So here is the sum of the y's, and there it is squared. So that is 737,881. So that's how you substitute into the formula. Now, it's one thing to substitute into the formula correctly, but it's another thing to be able to do this calculation. So here's how I want you to do it. The first thing you're going to do is calculate the numerator in your calculator. And you get 34,299. Then what you're going to do is calculate what is under each square root sign. So under the first square root, if you calculate this in your calculator, you get 44,187. And in the second square root sign, you get 33,563. Even from here, some people still make mistakes when putting it into their calculator, so this is the way I want you to type it in. 34,299 divided by the square root of 44,187 divided by the square root of 33,563. You have to divide by both of these because they're both on the bottom. And when you make that calculation, you get 0.8906. Your R values should be rounded to 4 decimal places. So we've got a fairly strong correlation between your first unit mark and your final grade, but it's not perfect, so there's room for improvement. So that concludes our day's events. So if there's anything that you didn't understand, please make note of it and ask your teacher in class the next day. We're just going to be practicing this really annoying calculation here and figuring out the R values between two sets of variables. So hope you enjoyed it as much as I did. Thanks. Bye-bye.